Okay, so now we're going to talk about what are called polynomial functions. So here comes the general form of a polynomial function. F of x equals a sub n x to the nth plus, okay, and now what we're going to do, so that looks like a power function there, but what we're going to do is we're going to go at the next term down. So it's going to be a sub n minus 1 x to the n minus 1 plus, and then at the end, you can have a sub 1 x plus a sub 0, okay? It's a little bit different in the book, but this is better form. You'll see the mistake. Okay, about those exponents. Exponents are natural numbers. So they're not fractions, they're not negative, they're not zero even. They're going from whatever your highest exponent, that's going to be the n, and then the next one, and the next one, and the next one, until you get down to just the constant, okay? So the exponent here is 1, right? Okay, so that's what the exponents are doing in a polynomial function. They're going from highest to lowest, and the constant number is at the end. Okay. The a sub n minus 1, dot, 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 to a sub 1, a sub 0, that is just matching the exponent on x. It's just to designate that they're different, what are called coefficients. And the coefficients have to be real numbers. They can be 0, but they have to be real numbers. Okay, so let's give you an example of a polynomial function. F of x equals x to the 5th plus x cubed plus 7x squared minus 3. Okay, something like that. All right. We call this first term, anyway, that would be a polynomial function. Let me scroll down a little bit. Oh, okay, we're not ready to do that. This is a polynomial function. I'll try to remember it and use it later. Okay, which of the following are polynomial functions? Well, in order to figure this out, you're going to have to multiply, do a little bit of multiplying. Now that's going to be 6x to the 4th plus 4. So I'm multiplying this part, 2 times 3 is 6, and then 3 plus the 1 is 4. That fits the form for polynomial function. So yes, this is a polynomial function. All right, what about this one? Well, I can distribute, and I get negative x cubed plus 4x. Yes, that is polynomial. My exponents are positive integers, 3 and 1. My coefficients are negative 1 and 4, so that's okay. All right, now let's look at this last one. You've got 5 square root x plus 2. Now you're like, well, what can I do with that? You can't distribute the 5 in there, not easily. You could write it as x plus 2 to the 1/2. But see, we're not having exponents now that are fractions. We're only having exponents that are positive integers. And so, no, this is not a polynomial function. Okay, now what we want to be able to do is we want to be able to identify the degree of the polynomial function. The degree is the highest exponent. So our example that I wrote earlier, x cubed plus, no, it was x to the 5th, plus x cubed, I think it was something like this. It could be different, but it was something like that. The degree would be the 5, so it would be a 5th degree polynomial, or we just say the degree is 5. Now the leading term is the one with the degree. So the leading term for our example here is x to the 5th. Okay, that's the leading term. The leading coefficient, well, that's the number that's the coefficient on your leading term. So our leading coefficient in our example is 1. Okay, I'm going to do one more example. This video doesn't seem too long. So let's say we have f of x equals negative 3x to the 7th minus 2x squared plus x minus 10. That is a polynomial function. It's written in order from the highest exponent to the constant at the end. So it's in the right order. It's in standard form. If they give it to you out of order, you just have to rearrange it. Okay, so what is the degree? Well, the highest exponent is 7, right? So that's the degree. What is the leading term? Well, it's the first term, negative 3x to the 7th. What is the leading coefficient? Well, it's going to be the coefficient on the leading term, which is negative 3. Okay, so we'll get some examples in the next video.